it's been great to be here with everyone in Dallas. Most of you know a little bit about Select Spectrum. For those of you who don't, we're a spectrum brokerage firm. We've done hundreds of transactions. We serve a variety of industries, but utilities and critical infrastructure is a very important focus for us. And we appreciate the opportunity to be here. So we try to be a place where you can come to ask questions about what's available. We try to give a full view of the different alternatives. And, you know, the news has been actually greatly improving. There's quite a few more different types of spectrum bands. I'm going to try something a little different today, though. Since there's a lot of frequencies, a lot of decibels, and a lot of megahertz, and a lot of watts, right? It gets to be challenging. So I'm going to alternate and talk about what applications make sense on what different frequencies. Now, in many cases, a frequency will support multiple utility applications, and in fact, there's a big drive with private LTE and ultimately private 5G to have networks that will support all these applications. Even so, some spectrum is better for some applications than others. And so I'm trying to give an example here. As you go through this and make your choices and look in particular at, for example, these bands. So what have we got? There's 6 different 4G, 5G bands, a couple examples of the narrow bands, maybe actually 3 because there's some overlap between the two. I certainly encourage you, and I think it's been great to have the kind of presentations we've had and the kind of discussion we've had from the professional consulting firms. So Bridgewater, I think, is coming up after me to talk about private LTE. That's great. Had a great conversation with some of the folks with Cell Plan yesterday. They're helping a number of utilities, Lockard & White. I highly encourage this. These are big, important decisions. They're going to last a long time. And we try to work with all of those firms and with the manufacturers to figure out what's the best solution in each case for each customer. Mentioned here, as I said, so we got 4G, 5G bands. These are all broadband at the upper left there. We have some of the narrow bands that are popular as well. And then the 700 megahertz A block sort of spans the both. It started in the narrowband world, and recently we've got approval from 3GPP. So it's a 4G, 5G band. It is not broadband, right? It has different characteristics. Some are advantageous, some are disadvantageous. So it's certainly worth talking about. And I'll talk about types of applications that it can support. All right. So an example. We're seeing this across multiple bands, but one of the bands we're seeing new networks going in to support distribution automation is at AMTS 220. So this is a band that was kind of in the backwater. There were some legal issues at the FCC. There were disputes between the license holders. All of that has cleared up now, and we've had a number of acquisitions within the past several years. So the company that should be our host utility, Encore, has acquired this spectrum here recently. The WEC has, Eversource, and others, and we're seeing in places where the range is very important, where the terrain is challenging, this can be a great solution. So if you want to run a distribution network across a wide area, relatively rural or forested or mountainous, this can be a great solution. It also supports voice solutions from certain manufacturers. So in this shift between application and band, here's the specifics of the band. It has a total of 1 + 1 megahertz. These are a couple of different licenses that can be operated as paired or TDD. It's available broadly across the country, although there's places where it's been fully sold out. It has excellent propagation, very high power limits, and we've seen successful deployments. One of the things this gets used for is positive train control. Not that interesting to this group, but there's usually plenty left over for utility or other critical infrastructure type deployments as well. So this can be kind of, and by the way, the general path here is start low frequencies and work to high. So obviously the longest propagation are at these low ranges, and that can be a great advantage. Okay, most of this is about data services. Most of the new effort that's going into networks is on the data side. Most of the growth is on the data side. But voice is critical when that basic communication, the ability to reach your your technical force and to get them to the place they want to be, to allow them to communicate with one another and back with central office. All of that is very important. There are this is an evolving technology. Some parties are moving towards LTE, others are moving towards really new DMR radio systems, digital mobile radio systems. So lots of capabilities. And these can be supported on multiple bands. So an example, and we see this very commonly, is 450 megahertz, right? It's a commonly used exceptional availability for utility DMR systems. Again, it can support data applications as well. In terms of the capacity here, total of 1.3 megahertz is available in Part 22 radio systems. So it's significant capacity, particularly for a voice system that normally is more than adequate. There's room left over for data as well. Very high power limits, long range, good penetration. People who have 450 radio systems tend to like them, use them, trust them. And one of the things we've seen lately is some of the companies that were previously offering push-to-talk services are starting to say, hey, it's getting near retirement time. I've got these licenses. The licenses can be more valuable than the ongoing business. And so they're willing to put those up. And we have represented some of those parties and sales to utilities. So it's a way to potentially significantly improve your data DMR capabilities. This was another decision that WEC made, by the way. As they said, this is a great spectrum. They're looking both at their voice and data requirements in general, and I think that's a wise approach. And they said, hey, 450 is what we're going to put the voice on. So seems like a good choice. Okay, we've heard about field area networks. To me, field area network is the predecessor to private LTE. It may be the long-term, and I'm talking about a field area network on industrial radio, not necessarily 3GPP solutions, supporting a wide range of applications, handling much of the capacity that a utility may require. 700, we're still getting excellent propagation with the industrial radios, also very, very good throughput. We have a number of companies. This, by the way, these frequencies, I'll be talking in a moment about 700, are supporting fans in something like a third of the U.S. population. So they're broadly in use in established bands. For a fan, you want to have something that will adequately cover your territory. And so this is a key territory and have adequate capacity. And over the last decade, we've seen a lot of companies move to this upper 700 megahertz A block as being an alternative for these frequencies. It's been substantially acquired here in Texas. So Encore is using the system. CenterPoint is using the system. Enterprise Products is an oil and gas company that is using these frequencies. So it's been very, very satisfactory to them. Because this is in the same vicinity, and you'll see well, it's adjacent to FirstNet from AT&T and the Verizon networks. There's plenty of equipment available for these. I think in the industrial radio band alone, there's a dozen manufacturers that support these frequencies, but you also have wide availability of antennas and cables and all of the amplifiers, receivers, all of the things that you need to make a good quality radio system. So this has been, I would say, our company's most successful offering, and we've worked. By the way, for those who didn't hear, we got the introduction as full spectrum yesterday from Terry Osmond. It's our company is Select Spectrum, but Access Spectrum also works with us in selling these frequencies, and they've been quite important into this industry. I should mention, I probably should have mentioned at the beginning, if anyone has a comment, question, suggestion during this, I think that would improve it. I'm certainly interested in those as we go along too. If I say something you don't quite agree with, please stand up. Mike is over there. He's been known to have a comment or two along the way. So by all means, have something to say. So that's the upper 700 megahertz A block. Significant news here, as I mentioned at the beginning. A little over a year ago, this was qualified as 3GPP band 103. So it's a 4G, 5G band. It's narrowband IoT only. There's not enough capacity to support broadband. Advantages of narrowband IoT. We heard some of these yesterday from Ali Shah and Nokia. Is very long range. They were saying 70 miles. I say 25, but I think 25 is enough for most applications. Low power usage, so this could be used for gas or water meters, electric meters as well. Moderate throughput, some latency, right? A second or more of latency. But if you're looking for a high volume application, this can be also a very good solution. And it's not part of the 3GPP standard. So we're talking about low-cost chips and modules. We demonstrated this actually for metering at UBBA. Demonstrated the switch from a private network over to the Verizon public network and back. So we're starting to see some pretty interesting types of applications. For the dozens of you who stopped by my booth yesterday, you saw that we also have a module, a streetlight control capability. And I think this is an example of all the different types of applications, line sensors that will come, because with that low-cost module in the device, it is an easy way to support tens of thousands of locations per field area. Okay, so I talked a little bit about what Lockwood and White calls heterogeneous spectrum layering. The carriers have different names of this, but it's essentially saying, okay, I'm going to use different frequencies for different applications, different frequencies for different locations, but I'm going to build a network that together makes sense and supports all of the requirements. And it's been done in the 4G, 5G world, and it was basically the basis for how most carrier networks were built, typically low frequencies at the beginning, and then going with increasing higher frequencies in areas where extra demand it was needed. So this is something that I think can make sense. Certainly encourage you to look at that, work with the professional engineering firms to sort through those capabilities. An example of this is indeed Encore, right? So Encore started with the 700 megahertz frequencies that they acquired. They built a network. They looked at capacity. They said, hey, that solved our system here more in what I call it northeastern Texas. Some people call it north central Texas, but we have issues in West Texas as well. So should we also acquire some 220 megahertz spectrum to serve those areas? And that's what they have indeed done. Oftentimes, you can use equipment from the same supplier to support multiple bands, and so you can build an overall network that is at the capacity you needed. And it's really designed for utilities and that kind of thing. There's advantages to 3GPP. It has this worldwide capability. It's a standards-based system. You can have interoperability. There's also advantages to systems that are designed for utilities to operate. It's targeted at you, not targeted at a mass market. There's no need to adjust from the mass market. So a lot of complexity in terms of what you're looking at. I guess I'm glad I'm on this side of the business and offering the services. And you guys, you have to figure out what the best solution is. But there's some significant engineering challenges. So that's what Encore did. I mentioned earlier, WEC Energy. They actually have both mission critical data that they're running on, and also they're using the voice systems. So we're seeing a combination. They actually have 3 spectrum bands altogether in these. So they're looking at 220 for long distance data in relatively rural areas, the 450 for their voice services, including into the city of Chicago, and then they have some 900 megahertz spectrum as well in areas where they have additional data requirements. You get that close, Dave? Is that on track, Richard? Okay. Okay. So we've been hearing more about the private 4G and soon 5G networks in this last year or so. I give great credit to Anterix for raising awareness of these kinds of capabilities. I'll talk through what some of the spectrum alternatives are, and again, look at different applications that might make sense for different frequencies. So first of all, a lot of this has been covered. I think you'll probably hear some more of it after this presentation. But 3GPP has great benefits, a worldwide manufacturing base, high volumes, lots of effort on security, interoperability, flexibility in terms of the range of services from narrowband IoT that will go long distance, low cost, low power, to ultra broadband, ultra low latency. So there's a variety of flavors. It's not just one thing, right? It's a broad ecosystem of different capabilities, different related technologies, and compatible overall. Although there's lots of understanding that's needed there, and there's lots of significant management efforts. We see this as evolving. We would recommend, as you look at this, for sure you want to look at a spectrum band that will be part of the 5G standards. Because if you look on your phone and when you go to the executive suite, it's already 5G, right? This is what the consumer world is increasingly expecting, and so you want to be in a situation where whatever you acquire, at least in terms of spectrum, if not also equipment, has either is 5G or has a path to 5G. So you've heard about those advantages. I think they're very valid. Here's a short list of the many manufacturers that support both this industry and the 4G, 5G standards. There's some on there that used to be just industrial radio companies, and they realized the importance of now being part of the 5G standard as well. If there's anyone here who is an active part of this and has equipment that actually supports 4G or 5G or a plan to do that within a given period of time, and you're not on the list, please let me know. We're working with a number of these companies on different frequencies where we hold frequencies or our clients hold the frequencies, and they are wanting to modify their equipment to support our bandits. You have, first of all, the standard, and then of course the companies have to decide, is my particular product going to support the standard in that particular band, right? So it's a three-step process. Okay, this is an example of a use case that's been trialed and demonstrated and appreciated by the New York Power Authority. The example was on 600 megahertz. They wanted to look at a wide range of applications. Their interest was in part on sort of productivity for the mobile workforce. They wanted to be able to fly drones, UAVs, in order to monitor their lines. They're a G&T type utility, publicly owned G&T utility. So they had some pretty broad goals. It happened to be that in the areas of New York State where they were, there was an investor who had acquired these bands. Most of the 600 is held by T-Mobile. Dish has some. It's generally not been available to the utility industry or even to the investors who sometimes will sell. Some of them are our clients who will sell into the utility industry. But in New York State, That was available. We actually helped get the lease done. They put in a system. They did it 600 megahertz. I think they did a CBRS system in parallel as well. They were very happy with the performance. And you can imagine, at 600 megahertz, broad consumer types of applications, so chips and modules widely available, great propagation, 10 megahertz, 5+5, so lots of good capabilities. Here's the band, here's the description. There's actually multiple frequencies. I think it's 70 megahertz altogether in 5+5 blocks. And in some cases, there's one or two of these that are available. By the way, it's relatively low uplink power, 3 watts, still adequate for most truck radio type applications, that kind of thing. But overall, could be a great spectrum solution. But unfortunately, it's generally not available, right? So it's a band that is worth checking into. If it happens to be available in your area, would certainly be glad to talk to you about who holds those licenses, whether they can be encouraged to sell them. I think for most of the investors holding these, they expect to eventually sell them to T-Mobile. But that's not happened yet in most cases. So in something like 20% of the US, this spectrum is potentially available. I don't think you're going to get it out of T-Mobile. So there's another band that's been discussed here recently. It's made quite a bit of press, so-called Band 26. It's the 800 megahertz licenses. These were acquired by T-Mobile in the auction, but as part of the merger, part of the acquisition of Sprint by T-Mobile, they agreed to provide an option for $3.6 billion for Dish Network to acquire these licenses. And Dish wants to do that, but Mr. Ergen and his team at Dish don't have the $3.6 billion. At least this is my interpretation, because they didn't exercise the option when it was due. They asked for an extension. Here's the sequence of events. Since then, Burns & McDonnell, a very respected firm in this business, has filed with the court, because this is because it was part of the merger. There's a Department of Justice decree that's being enforced by the court to say you should force Dish to either exercise or this spectrum should go to auction. That was the original plan. Well, there was some back and forth. The court has now said that by April 1st, Dish has to decide. By the way, Dish paid an additional $100 million for the right to extend that to April 1st. I think it was a 7-month extension. So to me, this indicates that particularly the extra $100 million indicates that Dish fully expects to complete this transaction. And this team has been capable of acquiring a lot of spectrum over the years, and they're now operating a significant network. So that, I think, is the most likely outcome. But it's possible that Burns & McDonnell, and they've said that Burns & McDonnell Group, I think, is the term that would represent some prospective users, maybe some utilities, could end up being in an auction to acquire the licenses. And potentially, then you would have those available for this industry. I personally am skeptical that this is all going to come to pass, and I'm also skeptical that whatever resolution is going to be resolved by April 1st of next year, because the courts are involved, and it's the kind of environment where I expect delays are possible. Okay, so back to the applications. I was talking about Flizzr and VoLTE. Here's two important applications. So voice over LTE, I think, was an important part of the Lower Colorado River Authority decision, as it's part of what they had looked at. This is my understanding from attending the UTC conference again. This is interesting because it has equal capacity up and down, right? Typically, your voice is going both ways. You need both those panels. Locating faults and resolving them, especially in the case, this has been particularly important in California, so far the West Coast. If you can identify that fault before the conductor hits the ground and shut off the power, highly important. So here's a couple of examples of the types of applications that all 4G, 5G networks can support. We had a great presentation about 900 megahertz broadband service. This is some of the types of applications that these are available. Great progress here is 4G spectrum today. There's an item at 3GPP that apparently has significant support and appears likely to pass, or it would become a 5G network as well. A significant challenge here is there are existing users. So far, not a lot of the counties have been cleared. I think Anterix is going based on where they have orders or interest. And so that would be something that I would look at in this. But certainly excellent propagation spectrum. So this is 3 megahertz up, 3 megahertz down. So if you have, like most utilities have more uplink than downlink traffic, then your capacity is set by that 3 megahertz. As is true in any system, but in an FDD, if you have more one direction than the other, there's some of it is not able to be fully used. Okay, another type of application, this was demonstrated also at, and that was really the emphasis, significant emphasis at UBBA, is direct-to-meter communications. So today we're using mostly 900 megahertz unlicensed systems. Those systems, my understanding, can be difficult to operate and maintain. Interference increases over time. You have the hopping through different devices, so there's kind of a loss of capacity through that additional hops. So each time it takes a portion of the overall capacity. So one of the solutions, and we think it's a solution that makes sense, is just go direct from the tower to the meter. You don't need necessarily a mesh network if you have licensed spectrum. And the throughput, it's not all the time these are on, but the throughput could be adequately handled. For gas and water, I think the consensus is NB is enough, just at 200 kilohertz. For electric, some say you want to go to Cat-M or RedCap. Others say, well, maybe NB-IoT is enough. So this is, I think, going to be very much an evolving system. All of the all the meter makers that we're talking to, this is in their plans. They're doing trials and development. And as we come to AMI 2.0, as the systems that were put in 2009, 2010, near the end of their life, I think we're going to see a lot of direct to meter. So we think band 54 is going to be a great solution, particularly in this case. Obviously, metering is predominantly uplink focused. This is a time division spectrum. It's in the lower portion of the mid-band, so the propagation is not as good as sub 1 gigahertz, but we're not far away at 1670 megahertz. We'll be talking about similar cell size in situations where capacity is the name of the game, particularly uplink capacity. 5 megahertz TDD, you can get the equivalent of 4+ megahertz of uplink capacity. You're not going to be necessarily using all of that downlink. So could be a way to get more, be slightly less expensive than buying 6 megahertz from somebody else. We think this is going to be very successful. It's already 5G approved. As of just this past month, we have the first chipset manufacturer officially announced, and they're delivering chips now. We have the first base station supplier announced. They're going to be delivering chips or delivering base stations next quarter. There's filters available from Qualcomm, so the ecosystem on this is coming together. It's not everywhere we want it to be yet, but this is a big part of what I'm doing these days, is talking to different suppliers and about how this is going to roll out. So what we're talking about is trials next year and deployments in 2025. So pretty excessive, significant progress there. All right, and we are working along here. I think I'm about on track in terms of time. Another type of application is where you really need broadband, but you don't need it over a broad area, not over a lot wide area. So CBRS is a technology that's widely available, lots of different suppliers. Spectrum is available to anyone on the GAA tier, although there's competition for that. It's essentially it's managed unlicensed spectrum, I guess is a way to think about it. And then priority access licenses are available in most of the country as well. So you can talk to us. We represent a number of parties that hold these. If you have this requirement to serve a campus, to serve a building, to serve a depot, to serve a substation, CBRS is probably fully adequate to handle those types of distances. And the cost can be certainly attractive. We're talking about 10 megahertz TDD per channel, and you can get multiple channels. So lots of throughput, relatively low cost. Is it good for covering your entire regional operating area? Probably not, right? It would be, maybe the manufacturers would love it. They'd sell a lot of equipment and the tower suppliers and the backhaul guys. But for those areas where you have a concentration, certainly a valuable thing to look at and probably part of an overall capability. The spectrum, by the way, the licensing is more complex. You have to pay a spectrum access system supplier, such as Federated or Google, for the use of their database that keeps track of all of this. There have been some glitches in the databases. It is a more complex situation, and I don't know that at this point I would recommend it for mission critical type applications. Is video monitoring of your substation mission critical? I'm not sure, right? These are the kinds of things that are worth thinking through. But the economics of this for full broadband can be quite compelling. If you're on the coast, by the way, there's issues. Also, the naval radars operate at these frequencies, so it can be some challenges there as well. Yes.
Mark, you go back.
Sure.
What type of speeds would you get?
So I'm going to give my comment, and I'm hoping somebody either says, yeah, that sounds about, but Paulo's here, I'm sure he could do this. So I would say 4 bits per hertz is easily achievable. 10 megabits means 40 megabits. So for per 10 megahertz, and potentially you could get 4 10 megahertz PALs in an area. That's the FCC limit. So with 10, it'd be 30 to 50. With 40, you do the math, but well over 100 megabits. Good per location. So lots of throughput, pretty interesting. Not very far as the choice there. And here's the rules. The key issue is there's indoor and outdoor systems at different power levels. There's a coordination with the SAS. We do have priority access license holders throughout much of the country who are willing to offer portions of those. What we think is going to happen in this market is there's maybe a company that bought the license for the county, but they don't necessarily care about where your substation is. So you could get, for a pretty low cost, that priority access license, means no other party can use that for whatever small area you want. And we're working on developing a kind of a marketplace for this. So pretty interesting for a certain set of projects, I think, or certain types of problems that you're trying to solve. All right. We think we invented the concept of the matrix for different spectrum bands. Everybody has a version of this. Here's our version, and I guess worth talking through. So all spectrum involves trade-offs. Here are some to look at: propagation, standardization, how much capacity. What capacity and throughput tend to be directly related. Is what's the in-building penetration, usually also related to the propagation, and then whether it's available or not. So these are the factors I'd encourage you to look at for your application. If you're dominated by propagation, if you want those longer ranges, look for sure at the lower frequencies and their advantages. And I would say in most cases, all the way through the lower midband is good propagation. If your focus is capacity, look for the wider bandwidth. In the end, of course, is it available where you want it, and is it available when you want it, are important situations. So here's the matrix. Comments, questions about that, or how it fits a particular need that you guys might have. I will say we are a little commercial position here. We're very excited about what's happening in band 54. We think that it has a very good combination for lots of utilities needs. We've been excited about what has happened in 700 megahertz over time, right? So a third of the utilities across the country, or critical infrastructure, I'll say, covering a third of the U.S. Holds those licenses already. And now they're also available for NB-IoT. So to the extent they have capacity left over, they could put on their channels for streetlight control, or line sensor monitoring, that kind of thing. Okay. All right. We do have a little more to go. So we've kind of covered the concept of multi-frequency layering in the industrial radio case. Well, it can also work, and in fact, I'd say in a way it was more developed in the carrier space. So T-Mobile has a name for this. My old job, by the way, was managing that mid-band thing for at that point it was Sprint. But they call it the layer cake. The super high capacity, the convention centers, the stadiums, they do that with millimeter wave. We have millimeter wave frequencies if anybody wants to go down that path. Most utilities don't care about that. But the broad coverage that they do at the lower band, we would recommend have a look at 700 megahertz as an example, right? It's broadly available. Certainly 900 megahertz broadband could do that as well to provide broad coverage. In the capacity layer, we would say mid-band is where the carriers are going. Have a look at that. You might find, like in a band 54, it actually has enough combination of power, because it has high uplink power, and propagation to serve really both those capabilities, but to provide both the coverage and the capacity. So this is a way that I think over time we're going to see the private wireless networks evolve, and maybe not quite to the ultra high capacity layer cake model, but this is certainly something we're seeing. All right, the last thing I want to just mention. There's been increasing interest in satellites. The band 54 spectrum that we're talking about, by the way, is held by Legato. It's a satellite company. They and others are also now offering NB-IoT over satellite. These are actually geostationary satellites, so it's not a broadband service, it's a narrowband service. But we've seen some utilities who have a dense operating area also want to look at how do I cover my remote areas. PG&E has a solution along these lines, and we've had interest from others as well. So the idea is not just stratify your network in terms of multiple frequencies, but an alternative or a supplement to that could be where you don't want to build towers, where you don't have enough demand for that, or just for backup, right? Because bad things can happen to that terrestrial network, even as much as you try and harden it and reinforce it. It's nice to have a degree of backup. So satellite capability is there as well. And it so happens that it's different frequencies, by the way. The terrestrial band 54 is just a terrestrial frequency, but Legato has one of our clients, we can refer you to them, and there's others, can offer also NB-IoT over satellite. So you can use potentially the same architecture. NTN is the term, non-terrestrial networks. Potentially you could use that same 3GPP architecture both for your terrestrial private 4G or 5G network, and also for satellite services to your remote sites. I mean, a similar thing is on your phones. Now, Apple and I think some others are offering the ability to make very limited text, I think only short message, standard message calls of like emergency, I'm in the outback and I've fallen and I can't get up or something like that. So that kind of limited throughput and greater than that, because it's not from a phone, it's from a remote terminal with some kind of significant antenna, can be available and map into your overall network. Okay, that is my presentation for today. I think, Keisha, I did okay on time. We do have time for questions, comments. Okay, well, thank you very much. I enjoyed talking with you today.